All right, other reactions that you can do, we're going to learn about 5 of them, I believe, is you can take your aromatic ring, add nitric acid, and then you have to add an acid catalyst. The acid they use is sulfuric acid. All right, that's acting as a catalyst. Now, you don't have to put H2SO4. You remember in chapter 4 I said other ways of showing acid catalysts is either an H plus or H3O plus, or you can just write acid catalyst. Okay, these are all the same way of showing sulfuric acid. But nitric acid is actually the reagent, plus your catalyst is sulfuric acid, and you get a nitro group on your compound. NO2, that's how you get nitro groups on your compound. All right, and actually water is one of your byproducts. Notice an oxygen and a hydrogen come out of nitric acid plus the other hydrogen. All right, so that's how you get a nitro group on your aromatic ring. Another one is if you want to make what's called a sulfonic acid, you add SO3. SO3 is kind of a stinky gas. It smells like rotten eggs. Anything with sulfur in it, that's gas, is kind of smelly. Same thing, you got to add a sulfuric acid catalyst, and you form sulfonic acids. These are common in a lot of medicines that we take, have sulfonic acid groups in it. And those are 2 more reactions. All right, 5.5 is what's called, 2 more reactions we'll learn, is what's called a Friedel-Crafts alkylation, and we're going to learn an acylation. Same thing, Friedel-Crafts alkylation and Friedel-Crafts acylation. Friedel-Crafts were the 2 scientists that came up with this. I believe they won a Nobel Prize because they are making carbon-carbon bonds. So, you have to have an sp3 carbon of some sorts, plus a chloride. So that has to be sp3 hybridized. Doesn't matter what groups, if you have hydrogens or other R groups. Basically, you add aluminum trichloride as your catalyst, and you can hook on that carbon group. Let's make a carbon-carbon bond. So let me show you a real example. Let's use isopropyl chloride. That was, I think, the one that they did the most to show this. It worked the best, but let's just pretend everything works well. And then you also form HCl. Let me put HCl up here. Your chlorine and your hydrogen form HCl. All right, so that is the alkylation. This is the alkylation because you're putting on an alkyl group. We've learned what an alkyl group is. The acylation